They're pretty much the universe's ultimate mystery. We're talking about objects so dense, so incredibly powerful, that they actually warp reality itself and just break all the rules of physics as we know them. So let's take a journey together to the very edge of space-time and dive into the enigma of black holes. And really, this is the question at the heart of it all. It's a question that pushes us to the absolute limits of what we know about space and time, to a place where, honestly, all the normal rules just stop working. Okay, so first things first, let's clear something up. A black hole isn't really a hole in the way we think about it. It's a mind-boggling amount of stuff, of matter, crammed into a space that's just impossibly tiny. This creates a gravitational field so intense, it basically becomes a one-way door in the cosmos. So to really wrap our heads around these cosmic beasts, we've got to look at their anatomy, right? Let's break it down and look at the key parts that make a black hole, well, a black hole. All right, first up is the event horizon. Just think of it as the black hole's edge, its point of no return. Now, it's not some kind of solid surface, it's an invisible line. But once you cross it, the pull of gravity is so completely overwhelming that there is no escape. Not for anything, no matter how fast you are. And then, deep down at the very center, you've got the singularity. This is where all that matter gets crushed down into a point that is infinitely dense. It's a place where our two biggest theories about how the universe works, general relativity and quantum mechanics, just kind of clash, and everything we know about physics goes right out the window. And yeah, spaghettification. That is 100% a real scientific term. As something gets close to a black hole, the gravity pulling on the side closest to it is so much stronger than the gravity pulling on the far side that it literally gets stretched long and squeezed thin, just like a piece of spaghetti. It's a pretty terrifying way to picture just how powerful these things are. Okay, so where in the universe do these monsters even come from? Well, their origin stories are some of the most dramatic, most violent events you can possibly imagine. For the most common kind, it all starts with a star, a really, really massive star. When it runs out of fuel, its own gravity becomes too much and the core just collapses. This triggers this unbelievable explosion we call a supernova. The star's outer layers get blasted out into space, but what's left behind is the crushed core, a brand new black hole. But here's the thing, not all black holes are the same size. You've got your stellar mass ones, which are born from the death of a single star, and then you have the supermassive ones. These are the absolute titans of the universe, and they hide right in the center of almost every big galaxy, including ours. And just to give you a sense of scale, let's talk about our own galaxy, the Milky Way. The supermassive black hole chilling at our center, called Sagittarius A star, has the mass of 4 million suns. 4 million! That's just a number that's almost impossible to wrap your head around. So this all leads to a really cool cosmic detective story. I mean, if black holes suck in all the light, if they're basically invisible, how in the world do we even know they're out there? I mean, this was a huge problem for astronomers for a long, long time. You can't just point a telescope and spot one. So they had to get really creative and start looking for the footprints they leave on the universe around them. And the solution was brilliant. They realized, okay, let's stop trying to find the black hole itself, and let's start looking for the chaos it causes around it. They could see stars whipping around a point in space that looked completely empty, or they could see this superheated glowing gas and dust spiraling in like water going down a drain. So, using all those clues, scientists could make simulations, basically computer models, of what they thought a black hole would look like. They predicted you'd see this shadow, a dark circle right in the middle of all that glowing, hot gas. For years, a picture like this was the best we could do. It's not a photo, it's a prediction. But here's a twist. Seeing a shadow, that's not the only way to find one. There's another method, and it might be even more mind-blowing. Turns out, sometimes, you can actually hear them. We can listen for the echoes of some of the biggest collisions in the universe. It's a sound that doesn't travel through air, but through the very fabric of reality. You see, when two black holes spiral into each other and merge, it's such a violent event that it sends out these powerful ripples through space-time itself. We call them gravitational waves. As they get closer and closer, just like you see here, the waves get faster and faster. And our amazing detectors here on Earth can pick up these tiny vibrations and turn them into a sound. It's this famous chirp signal. And that is literally the sound of space-time itself ringing like a bell. So we've done all this incredible detective work, right? We've gone from a wild idea to actual, solid proof. But you know how it is with science? Every answer just leads to more questions, usually bigger and even weirder ones. So let's recap. We figured out what they're made of, we know how they're born, we've proven they're real. But the biggest questions of all, they're still locked away inside. What actually happens when you cross the event horizon? What's going on at the singularity, where our understanding of physics just fails? You know, black holes are like nature's ultimate physics labs. They push gravity to its absolute limit. And trying to understand them, well, that's really about trying to understand the deepest secrets of our own universe. And the best part is, the biggest discoveries, they're definitely still to come.